Hello, my name is Leo, and this is a project that I've been working on which showcases Cisco router and switch configuration and demonstrates core networking principles and concepts including DHCP, router on a stick configuration which implies VLANs, as you can see VLAN A, B, C, and D, link aggregation which improves bandwidth between switches, and also manual routing which I configured on these switches as well. So just to begin this, I will start off with some pings between computers to show that there is in fact communication. So let us set that up. And once I have this set up, I will also show get into the configurations of the routers and switches. So let's go ahead and set up DHCP on the PCs to automatically retrieve IP addresses and gateways and subnet masks. And as you can see, PC1 used DHCP and it successfully retrieves from the subnet mask, or sorry, the subnet using the gateway which was assigned and the subnet mask. And likewise for this PC and this PC. Now I will try to ping across the network on a different router. So this is going from PC1 to PC8. So I will do ping 192.168.40.11. And the reason why it starts at .11 is because when I set up DHCP, I excluded the first 10 addresses because I know this is good practice in industry to reserve a few IP addresses for specific devices. Maybe you want it on a server or maybe you want it on another computer. But so as you can see, this ping was successful, and because of the way that this was sent, I know automatically that it works the other way. And you can in fact actually just check it in the ARP tables. There you can see there's entries for the corresponding PCs, but just for the sake of demonstration, I will ping back. So that is 10.11, and as you can see, it works. So now let's just go ahead and look at PC3. So I will go ahead and ping PC1 to PC3. So this is intra-network pings, but across different VLANs. So this is PC1 to PC3. So I will ping 192.168.20.11. And as you can see, it now works. And if you look in the ARP tables, you can see the entry there and the entry there. Now that we have that all complete, I will now show the configuration in switch 1. So if this is switch 1, and if we look in here and I do show run to look at the configuration, we will be able to see all the specific settings that I've configured and each feature that I've configured. So let's go to the bottom so that way I can show you all the features. So if we start from the top, we can see that I have starting looking at the interfaces. This is switch 1, so it has interface 1.1, 1.2, 1.3, 1.13, 1.14, and 1.15. So if we look at the corresponding interfaces, 1.1, 1.2, and 1.3, they all have access to specific VLANs, and you can see that here, switch port access VLAN 2, switch port access VLAN 3. And if we go down to 13, 14, 15, these require switch port mode trunk because they need specific headers to indicate that there's VLAN tagging, which is 802.1q. And if you notice also on 1314, there's something that says channel group 1 mode on, and this is due to me configuring link aggregation between these two switches. So you will also see this on switch 2. And this is basically just assigning this to the port channel. So now if we look at router 1, we can do the same thing where we look at the configurations. And so I will take you through this configuration. So starting from the top, we can start to scroll down here, and right away we'll see DHCP. And as you can see, as I said before, I set up DHCP for each VLAN. So this is seen here with the 10.1, which is VLAN A, and 20, which is VLAN B. And this excludes the first 10 addresses for the reasons that I said before. You might want this for the gateway to exclude the gateway address or specific reserved addresses you want for devices. And we can see this is the VLAN pool I set up for, the DHCP pool for each VLAN. And if we scroll down here more, we can start to look at the interfaces. So as you can see in router 1, there's interface F00, which is for the router on a stick configuration. And you can see it has sub-interfaces point 2 and point 3, which indicate the VLANs that I've created. And you can see this as well, the .1Q, which indicates VLAN heading or header tags, and it shows the gateway address for the subsequent subnets in the VLANs. And if we scroll down, we can also look at the serial connection 00, and this is the connection from router 1 to router 2. And we assigned an IP address, point-to-point link IP addresses for all of these interfaces on the routers 1, 2, and 3, so that way they can have connections with each other. And because they're serial connections, we did encapsulation PPP. And as you can see, I had to create manual routes so that way I can go from this side of the network to this side of the network. So let's go back to router 1, and you can see here, for example, if I want to, from this network, from the left-hand side network, if I want to reach VLAN C, which is 192.168.30.0, then I have to manually configure this. So I will start at router 1 and I'll say IP route and then the destination, which is 192.168.30.0, and then the subnet mask, which is /24. And then I will use the neighboring IP address, which is 192.168.0.2. And I did this in similar fashion for the remaining routes. And if we actually look at router 2 really quick, we will be able to see this a similar concept here, but this one actually has more routes just because it's not like an edge router similar to router 1 and 3, it's in the middle. So it needs 4 routes to go to all 4 VLANs. So as you can see, there's corresponding subnet addresses for each VLAN and corresponding neighboring addresses, so that way I can set up the routes for these to work. And this basically demonstrates the setup that I had to go through to create this topology for this project, which showcases the Cisco router and switch configuration. And thank you for watching.